Hello everyone, my name is Anton Boyko. I'm from Ukraine. I'm a Microsoft Azure MVP and also Microsoft Regional Director. And today I'm here with you to talk a bit more about my favorite cloud, which is Azure, as you can understand, and also to show you what cloud actually means. There is a really cool, basically a new direction where all the cloud providers are heading right now, and the general direction is called serverless. And today we will be talking about Microsoft Azure Functions, which are the serverless offer from Microsoft, and I will show you how awesome it works, how easily it's to scale it, and so on and so forth. So let's get actually started. And I would like to start with sharing my screen with you. So for now, what you're seeing here, you're seeing the Azure portal. And on this Azure portal, for now, the only thing that we have is the service bus namespace. And right now, we will be creating a really simple application with you. So this service bus namespace, I do have one queue inside, and we will create a dummy application that will work as a task processor. So let's say that someone, literally someone can put any task into that queue, and then on my side, I will try to process that task as fast as possible and also scale if needed on demand. So let's actually start with the creation of new function. What we need to do here, I just hit create, and here, yeah, got it. Here I need to look for function app. Here it is, function app. And here create function app. Here I need to fill basically all the details, and again, as you can see, you can run code, you can run Docker container. In this particular case, we will create a simple Azure function and we will edit it directly on the portal, but the idea is that if later you will need to basically create some function which you can debug, deploy, test locally, and then compile it into the binaries and then apply it here, that will also do. But for now, for the sake of the demo, I will do everything on the portal just because it's faster. I need to provide a unique name here, so let's call it TechDemo02, while TechDemo02, because today, to make sure that everything is working, I basically did the same, and I just named it TechDemo01. So now we're doing 02. The runtime stack is .NET, the version is 6, the region is West Europe, just because this is the closest region to my location where I am right now. And we will be using the consumption pricing plan. I will talk about the consumption pricing plan a bit later. Now let's just finish with everything here. Now for the hosting, it will also automatically create a storage account where the actual code of our application will be stored. Then for the networking, we can't change anything, which is fine. And for the monitoring, it's really important that, as you can see, I would like to create a new instance of the application inside, which is TechDemo02, just to show you on the monitoring how the scale is actually working. That's basically it. Review and create. It will take a few minutes, and meanwhile, I will tell you what the serverless pricing plan actually means. So the big idea behind serverless is that, first of all, you don't need to manage any servers, which is awesome because basically now, as a developer, you're concerned only about your code. But the other cool part of the story is that I can deploy my code there. The reason why it also creates a storage account for me is because that code, it will be deployed into that storage account and it will be saved there. And the serverless pricing tier of Azure Function, it can scale down to 0 instances. So technically, my code is there and I'm paying like 1 cent per month just to store my code there. This is kind of just an approximate price, but nonetheless, And while I have no traffic to my application, Microsoft will charge me nothing for the function itself, for the API, I mean. But when the traffic will start to arrive and when this function will start to scale up from 0 instances to I don't know, like 10, 20, whatever will be required to handle all my traffic, I will be charged by each execution and by the amount of resources that was required to finish that execution of that function. So basically, Microsoft will do the microtransactions and charge me for each and every request. I don't remember the exact pricing, to be honest, but it's something like for each 1,000 requests, you will pay 1 American cent. So let's go to the resource, to our newly created function, and see what we can do here. Let's go to the functions, and let's create our first function here. So we created the function app, it's like a web app, and now we will create the actual function within. So I will go with create, and here, as you can see, I will choose the option develop in the portal, and I will be using this template, Azure Service Bus Queue Trigger. I need to provide a template details, so this is the name of the function. Let's just use Service Bus Queue Trigger 1. So the Service Bus connection, there are no connections here, so let's create a new one, and I would like to connect to TIG-Demo02 service bus, and I would like to use root manage shared access key. And the queue name here is my tasks queue. Oh, sorry. Queue, if I'm not mistaken, that was the name of the queue that I've created there. Create. And again, in a moment, what will happen, it will create right here on the portal a very simple code, a very simple function. Let's just go and see what do we have inside. And that function, it will automatically bind it to the service bus, to that particular queue. So each and every time I will have a new request in my queue, that request will trigger this function execution. Okay, so now I just want to add a few more things here. So first of all, sorry, that was my bad. So first of all, I would like to do this one. I would like to use the namespace system threading, and here I would like to do something like thread sleep, and I don't know, let's say that I would like to sleep for 3 seconds. In that way, I will kind of emulate that something is actually happening within that function. So that function is not empty. It takes something like 3 seconds to process the message. On that one, I can save it. And that's basically it. My queue consumer is ready. So now let's try to send a bunch of messages here and see what will happen. What I will be also needed to make it happen, I will also need to go to my resource group here. I will need to go to my queue, TIG-Demo02, and I will need to copy this particular key, the primary key or the secondary key, it doesn't matter, because the other thing that I'm having here, oh, sorry, not on that screen, sorry. The thing that I'm having here is the application, the producer application, and here I just need to replace this connection string, that it's actually exactly the same, so awesome. What I do have here on my producer side, as you can see, it's a simple console application. It will be using the connection string for the service bus. It will use the queue name, the same queue name, my tasks queue, and then it will send 5,000 messages to that queue, it will take a few seconds to send all those messages there. But on the other side, what we will be doing, we will be monitoring our Azure function, and we will see how it will scale on demand. So let me just open the window that I need on this side. So I will need to go to application insights of my Azure function. And I will need to view the application insights data, and here I will go to live metrics. So we will see everything, how it's actually, how it will happen live. So what is important here, let me just scroll down a bit. As you can see, currently there is only one server here. So technically, there should be even like 0 servers here, because the function, as I was saying, it can scale down to 0 services, to 0 servers, but because we just created it and because we just edited it, so that's why this one server is here. But nonetheless, what we can see on the other metrics, that the request rate is on 0 messages per second. The request duration is also empty, so nothing is really happening here right now. So let me switch back here and let me actually send that 5,000 messages I was talking about. And the application is compiling and the application is running. As you can see, it starts to send all those messages. As I was saying, sorry. Yeah, I forgot one detail, that I can send only 1,000 messages in one batch. Sorry, so I will send only 1,000 messages here. Sending 1,000 messages. Okay, works fine. It took like almost 3 seconds. Now let's switch here. So for now, as you can see, this graph, the request rate starts to increase. The duration also is around 3 seconds, basically our thread sleep time. But the most important part is here. As you can see, currently we have only one server, but at some point, as you can see, now we have 2, and we will be having even more. The idea here is that the Microsoft on the Azure side, they will monitor the queue itself, and they will see that the amount of messages that are actually stored there in a queue unprocessed starts to increase. And because that amount of messages starts to increase, that will also mean that we may not have enough compute resources to do that. So that is why it will throw more compute resources here. So for now, we still have only 2 servers, but you know what? Let's actually run this application a few more times, and let's just add a few other 1,000 messages to the queue. Sending one other 1,000, okay, and let's do it one more. So in total, there will be like 3,000 messages in a queue. Okay, we are done. Let's see what will happen here. So what I want to show you is that at some point, it's actually even happened already. At some point, even 2 servers was not enough, so Microsoft creates 2 more, and now we have 4 servers that are processing our queue. The other interesting part of that is that, as you can see, the CPU load is actually quite small. The reason for that is because we're not actually doing anything. We're doing just a good old thread sleep, and that's basically it. So that is why the CPU load is really, really small. But as I was explaining before, because in this particular case, Microsoft monitors not the load of the server, but the length of the queue, and the amount of tasks there is accumulating, and we are not processing them fast enough. That is why it's throwing more and more resources. Here, as you can see, we have 6 servers already, and I want to highlight a few interesting details here. So the first detail to highlight is that if you noticed, when I was creating my Azure function, I didn't configure any autoscale, basically nothing. So I create the function from the scratch. It took me like a few minutes, and that's it. It's already there. It's ready for work. It's ready for scale. And the other detail that I would like to highlight here is that when you're working in a cloud, the cool thing about the cloud is that it will cost you literally the same to either ask for one CPU that will work for 60 minutes or to ask for 60 CPUs that will work for 1 minute each. At the end of the day, you will pay the same. They will charge you the same. So that's why with this new and fancy approach, with this cool technology, what you can do, you can scale on demand. You can guarantee that the average processing time, for example, of your messages will be predictable. If you will need more resources, Microsoft will get those resources, will provide those resources for you. And even if it will happen like 3 a.m. at the morning, still you don't need to wake up. Everything will happen automatically, and then everything will be scaled back down. This is really the cool part of it. And here I was showing you basically the example for the messages in a queue, but in the same way it will work with HTTP requests and so on and so forth. So I really encourage you, if you want to try cloud, if you want to feel basically how awesome it is, how awesome the scaling is, how easy it is to master the cloud, I really encourage you to start with the serverless offering, and especially with the Azure Functions.